In this lesson, we're going to talk about direct variation. Direct variation is a common variation where y and x are related by a constant ratio or constant rate. It's represented by the equation y equals kx, where the k is called the constant of variation. Constant of variation is always a set number. We're going to use an example here. Let's say y equals 3x. Now this could represent a real-life problem like saying that tickets were selling for $3 per ticket. And so if we have this constant rate of $3 per ticket, then all of our problem will revolve around that $3, that constant of variation. So obviously if we buy or sell 5 tickets, we would plug 5 in for x, and multiplying 3 times 5, that would mean that our total ticket sales were $15. Now that's a simple example, but that is a fixed or a constant rate of $3. If we look at a table representing these values like this, we notice that when x is 0, so is y, and that's always going to be true in a direct variation, that 0 of x will be 0 for y. Then we notice that 2 represents 6. 2 tickets in our previous example would be $6. 4 would be 12, 6 would be 18, and 8 would be 24. One of the things we notice as we look at the table is, as the numbers in x increase, get bigger, the numbers in y also increase. They go the same direction, and that's important also. Now, our constant of variation, k, this part of the equation, y equals kx, if we wanted to compute our constant of variation, we could do that simply by a little algebra here. We just divide both sides by x, and therefore we would determine that k is equal to y over x. So if we know our y and x, that's our constant of variation. You'll notice that if we take any of the examples on the left-hand side in the table, any y over any x will always be the same amount. The 6 over 2 will be 3. The 12 over 4 will also be 3. 18 over 6 will be 3. And 24 over 8 will be 3. All the constants of variation would have to be the same in order for this to be a direct variation. Anytime you were to graph this, you'd find that it's a linear graph if you were to plot these points and connect them with a line, and in fact you would find that that linear graph always crossed at the origin at 0, 0 as a starting point. So let's look at an example of a kind of problem that we might have to deal with direct variation. Look at this right here. If y varies directly as, and sometimes you'll use the word with, directly as x, and y equals 10 when x is 5, what is y when x is 11? So what we need to find first here is, what is that constant of variation? Since we're given y and x, we can find that k. Remember, we found just a minute ago that k is equal to y over x. That's our fixed ratio that we used as part of our definition of direct variation. So we simply take 10 for y, 5 for x, and 10 divided by 5 is 2. So k is equal to 2. Our question didn't say what is k, it said what is y. But once we know our constant of variation, since we know that it will be the same for all values of x and y, then we'll just compute that by using our original equation for a direct variation, y equals kx. In this case, we now know that k is 2, and our problem told us that x is 11, so we'll plug 11 in right here, and therefore, using direct variation, when y is 10 and x is 5, then if x is 11, y must be 22, which you'll notice is 2 times the amount, which is our constant of variation that we just found, of 2.